Welcome back, everyone. So we've almost got this first video set wrapped up, but there's one more topic we'd like to share with you, and that is the topic of occlusion culling. Now let me go ahead and say this quickly. Occlusion culling is only available for those of you that have Unity Pro. So if you've gone out and downloaded Unity Standard, the free version, you will not have this feature. I am sorry, because it is a very impressive feature. It's very important when it becomes time for performance tuning. But kick back, enjoy, because you'll still pick up a few things about what is available in Unity Pro, and maybe it'll get you thinking, that could be useful to have for some of my awesome games that I'm going to be designing. Now, occlusion culling is, like I said a second ago, a very important performance aspect of getting your game to play back quickly. What it is everything that's sitting in our scene. We've got all these 3D objects. Objects that are further away from our camera get rendered first, and then as we start getting into objects that are closer and closer to the camera, those objects get rendered. Well, what happens if you have an object far away, but then between that object and the camera we have a wall? Doesn't it seem like it's a bit of a waste to render the object that's past that wall that we cannot see, that has been occluded by the wall? Now, by default, we get frustum culling. Frustum culling has been around for quite some time, and that is objects that are not being seen by the camera. And I'm not talking about the objects that are in front of us that are behind the wall, but I'm talking about the objects that are to the left, to the right, or even behind us right now. There you go. So Lee's backing out so that we can get an idea of exactly what I'm talking about. So you can see that, point it towards the building. And right behind the camera, we've got a box, and we've got several boxes, and there's a wall back there as well. Those things will not be rendered, only the things that the camera can see. And again, that's frustum culling, and you get that automatically, even those of you using Unity Standard. But we come back to the problem of what's known as overdraw, and that is when objects that are further away, that are being occluded by some other object, having those objects draw is really a waste of cycles. It's just a waste altogether. So occlusion culling gives us a way for the system to go in and calculate what things should be visible from any given point within a specified area. And we'll get into talking about how you set all of that up and you control the various parameters to allow you to fine-tune the data that gets baked out, because you could have a lot of data, you could have a very small amount of data, and depending on what you're targeting your game for, say a mobile platform, you're not going to want to have a large amount of data sitting out there. So you're really going to want to take a look at fine-tuning exactly what gets saved out. But we'll cover that. But as you can see, occlusion culling is very important, because if we had multiple rooms and we're standing in one room and we have our camera positioned just right to where if every single thing rendered that the camera would be able to see, occlusion to the side. So let's just don't think there's any occlusion right now, which means we may see a wall that's right in front of us. Then there may be a hall beyond that over to the side, and beyond that's another room, and then another room. Even though the player looking through the camera doesn't see those objects because you have that wall right in front of you, all of those other objects are being rendered. So occlusion culling, very, very important. But the scene we have right here poses a bit of a problem in giving a very good demonstration of occlusion culling. We don't have any large walls or buildings, anything solid that we could really stand behind to block our view. I mean, you may be thinking, well, what about the little building that Lee has right there? Well, it's more or less a roof with a bunch of columns holding it up. That's not really going to work for us.
Right, the columns aren't big enough to obstruct enough of the view for occlusion culling to actually take effect.
Exactly, and the same thing applies for all of those small boxes as well.
Right, this level was more designed for development of the character control system and the camera system itself. So what we're going to do is, like we did with the light mapping videos, we're going to build another scene that is optimized to teach you what the options do inside of that particular element of Unity.
When you jump into the occlusion culling panel. And not only that, but when we jump over into visualization, where you can start fine-tuning the results you get with occlusion culling, we'll be able to see what's happening so much easier. Here, we could make it work, but to be honest with you, we would really need to bring in some large cubes and scale them out like walls, maybe put them in the center. And we did that. We were like, man, now we're kind of messing up the whole look because we don't have light maps baked out for it. It's no fun. So in this video, as Lee just said, now that I've given you just a quick idea of what occlusion culling is, if you're new to it, we're going to build out another scene, another level, but something that's more applicable to occlusion culling, something that has rooms and we can run around with a character. So we will be using our character system that we've developed, and we're going to have 2 rooms with a hallway, and we're just going to throw some props in, and then from there we'll move on in the next set of videos and we'll start talking about what exactly takes place with occlusion culling and show you how we could set it up, and you can see the actual effects of it. So Lee, with that, let's create a scene that's, well, more occlusion culling friendly, if you will.
All right, and as Jason was mentioning, we're going to be building a whole new scene from scratch. We're actually going to do it all inside of the Unity editor. We're not going to jump out to Maya and build it there. We had mentioned in one of the previous videos that if you really wanted to, you could actually build a game level all inside of Unity.
That's right.
And we're going to do it. It's going to be very simple. It's not going to be the best looking level of all time.
Let me piggyback what you just said with this. Now, we all know this, but just a reminder, at this point, if you're an experienced Unity user, you can stop the video and jump on to the next video. This is really targeted for those that are new to working with Unity. So my thought that I shared with Lee a little bit earlier is, instead of just bringing this level in and having it complete, which, you know, we could have done that and just moved right into it, let's just build it for them. Just build something completely from scratch so that we have lights in a scene and we've got a roof and a floor and walls and a hallway and the whole 9 yards. You know, it's just going to take us an extra 10 to 12 minutes, but again, that's the convenience of videos. The only real pain is the fact that we're recording it. But for those of you that are watching, you can hit stop, you can fast forward, move on to the next video, whatever. So let's go.
All right. To start, we're just going to go ahead and hit new scene to create a new scene. I'm not going to save anything here. This was just for moving stuff around to show you. So we'll hit don't save. We've got our fresh scene. So
I'm going to go ahead and save it up under our scenes folder.
Sure, we'll save as. So we'll do save scene, go to our scenes folder. Let's give this an occlusion test level, abbreviating occlusion. So hit save. We've got our scene saved. It's now right here. Go ahead and close this up. And to start everything off, we'll go ahead and create an empty object. This object I'm going to hit F2 to rename. I'm going to give it a name of room 1. We're actually going to have 2 rooms, so to start off with, I'm creating a top level game object that I'm going to zero out. This is going to hold all the objects that we use to make the first room. Once we're done creating the first room, we'll actually duplicate this, move it off to another position, rotate it around to make our second room.
So right now it's kind of acting as a pivot point that's going to become the top level, the parent in a hierarchy of walls.
Yes.
Okay? For those of you from Maya, it's we just made a group.
Next thing is to create a cube. Go ahead and zero out its transforms. I'm going to turn this cube into the floor, so I'm going to set it with an X and Z scale of 10 because it's a floor. I want it to be fairly thin, so I'm going to give it a height of 1. Go ahead and hit F to zoom in, rotate it around so I can get a look at what we're starting off with. So this is our first cube. It's going to be our floor. Put it into our room hierarchy, create another cube, and this cube will be our first wall. So going to scale it 10 in X. Y, I want our room to be 5 units high, so I'll give it 5 for Y, and we're going to make it fairly thin, so its Z is going to be 0.1. Hit enter. Now what I want is this wall to snap to this back corner of our room.
Just a little, yeah, thank you.
So to do this, what I'm going to do is position our camera so I can actually get a good view on both of these vertices.
Now, since Lee is using very solid numbers, if you will, it would be very easy to simply punch in the correct numbers to position that. But Lee is going to demonstrate one of the new things with Unity 3, and that's snapping.
Right. So what I'm going to do is I'm going to hit W for move, hit V, and then as I move over different vertices on our selected object, I have our pivot point moving to match up with that point.
It's not really the pivot point that's moving. It's just your translate tool.
True.
But
it looks like the pivot point,
like,
but it's
yeah.
actually the transform tool. So what I want is to take this vertice that's on the lower part of the wall closest to us.
Okay.
Hold the mouse button down. This enables the move, and then I can position it to the other vertice that I wanted to snap to. In this case, it's going to be this lower back corner on our floor. Let go of the mouse, let go of the V key, and our wall is now snapped in place.
Yeah, they're snapping in Unity 3. It's sexy. It really works well.
So the next thing I'm going to do is take this cube, again, move it down to our hierarchy, hit Control D to duplicate this wall, move it a little bit, zoom in, same trick, hold V, select the corner that I want, and then hold the mouse button down, move it to the corner I want to snap to. And it's as simple as that. And then we just repeat that over and over again until we get our first room. Next thing is create another cube, zero out its transforms. In this case, because I know my numbers, as Jason was saying, for me it's fairly easy to just go through, type in the numbers I want, or I could just duplicate this, rotate it 90 degrees and snap it into place. So I'm just going to punch in a couple of numbers. So this one's actually going to be size 10 in Z, 0.1 in X, and 5 high. Now that it's created, I can go ahead and hit V, select this back corner, put it down in the lower corner. Now the reason I prefer just creating a new cube and then zero it out instead of taking one of these and rotating it is I prefer to work in this method so all my rotations are zero. It's just my preferred way of doing
otherwise
that.
you would have needed an empty game object to serve as your pivot point for...
Oh, if I wanted to duplicate more than one, I would have to parent them together under another game object and then rotate that game
Exactly,
object.
if you wanted to grab both and do it at the same exact time.
Correct.
And there's nothing wrong with doing that. It's just
matter of preference
Another work
and how deep you want your hierarchies to actually be at the end of it. So now I've moved this back wall that we just created. I put it into our room. I'm going to hit Control D to duplicate it. I'm going to move it to position it. Now this front wall is actually where our door is going to be. So with this wall we can't exactly cut out a piece of geometry. So to make a door, I'm actually going to scale this wall down to 4, move my camera so I can see where I want my pivot to snap to, and snap it into place. So now I've got one side of the room. Take this cube, duplicate it, move it off to the side so I can grab the right piece of geometry, snap it as well. This gives us both sides of the room. We still have to work on the transom above the door. So take this cube, duplicate it, this time set its width to 2.1, its height to Y.
Its height to Y? Wow, that's a cool setting.
Yeah, but it won't work, so
I'm just
set Y to 2.
So we'll do 2, okay.
Alright, so select my corner, put it into place, and look at it and see that I've actually made it too big. I always go the wrong way, so technically I want this to be 1.9. Again with snapping, get the right corner, snap it in place, and I failed
Still
again.
Looks a little short. Looks like 2.0 might do it nicely.
Yeah, let's try it.
Dink.
Wow. What do you know?
Hey.
You got it.
Well, what size are the walls again on the outside?
Well, it's
Those?
6 total, so it's 4, so it would do it. It was just the way I was snapping it before. They
Darn it!
line up
You said
right.
that not exactly how I thought. I thought you were going to say 4, and I was going to say, and 4 times 2 is plus 2 is yeah.
But I try to keep you on your toes, so I do it backwards.
I know. It's all done on purpose. You have an evil plan. Okay, sweet. So we're missing one thing. If it rains, we're in trouble. So we might...
Well, that unless we're making a swimming pool with a door, but that wouldn't hold water.
That wouldn't
very
hold
well.
water, so you'd be fail, Lee.
Yeah.
So we need ourselves a ceiling.
Yep. So I'm going to take the floor. I'm going to duplicate it, move it to a position. Makes it easier to pick my vertex that I want to work with. Snap it into place. Now I have a completed room as far as geometry is concerned. But we want to put some textures on it. So for textures, I've already created some from the other level inside the materials folder. The one I'm going to use is this level_cm-roof. So select that.
And the reason you're applying materials now before the entire thing is finished is, as you said at the beginning of creating this very simple level here, you want to duplicate this. So you don't want to have to do double the work. So if we can set this room all the way up and get materials applied, then when you duplicate it, it's going to duplicate all of those relationships. Well. Exactly.
And I only have to attach materials at one time. And with the way Unity handles materials, we have to drag them onto each object individually. This just saves us time. So let's create our material. This material I'm going to call wall or walls. So let's give it a color. Makes it easier to determine what I've already applied the material and what hasn't.
Honestly, Lee is not trying to make it feel like we are creating some sort of I don't know, asylum. Because it's going to start feeling like that with the floor and then these walls, and once you get some light in there, it's like, wait a minute, I see what you're doing.
Some 1960s, 1970s hospital in a horror flick.
Exactly.
No, I'm not doing that at all.
But this will enable us to see the visualization panels effects in our viewport when we want to see what's happening with our occlusion culling that we bake out. And that'll make much more sense coming up in a couple of videos here.
Right. And with the materials applied to all the walls and on our floor, our first room is done. So what we're going to do is select our room. We're going to flag it as static, tell it to change all of our children objects to be static.
And let me jump in real quick with that. The reason he did that, we're not planning to bake out any light maps in this level. We're just going to throw in some lights and you'll be able to see well enough. But light maps, as they required having static checked for generating those light maps, occlusion culling requires static also to be checked for view occlusion culling. We've got view occlusion culling and we've got target occlusion culling, which deals with objects that move. As if, an example, we had a scene that had a city with a bunch of cars driving around. I believe that's an example Unity themselves use.
Yes. Those
cars, they're not static. They are moving. But as soon as one of those cars turns behind a building, it's occluded. You don't want it drawing out. So that is an example of where we'd want to use target occlusion culling. In this case here, where Lee is setting up walls, and in a second a hallway, this is where we would want this to be our view occlusion culling. So this is static, and we need to be able to tell the engine that, look, this is static. This is what you're looking at when we're baking out this information.
Correct. And because everything in our scene is not going to be moving with the exception of our character, we have no need of target occlusion. We never want our own character to be occluded, so we don't need it, at least for this level. If you had a level that had a bunch of moving objects, then you would definitely need to use the target occlusion. So with that, our first room being modeled out and materials applied to it, with the fact that we've created a hierarchy for it, all we have to do is duplicate it. Hit Control D. I'm going to rename it to room 2, translate it 20 units in X, and rotate it by 180. Now, if you notice, we had a little bit of blue or a mesh being drawn. That's just a drawing artifact. As you move your camera around, it goes away. So if you saw that, don't worry about it. It's just, like I said, a drawing artifact. So now we have our 2 rooms. So we'll go ahead and create another game object, empty, call it hallway, and we'll use this to create all of the objects that we want for the hallway. First, we're going to start with a floor object, so another cube. Set its translation to 10. Y0, Z0, scale 10 and 10, and for X and Z, and 0.1 for height. Now the reason I'm using these particular units, which are the same as the floor for our other rooms, instead of something narrower to represent a hallway, is because I want to use the same floor material on the hallway without having to duplicate off a material and having a separate material just for this hallway.
And that separate material would be just so that you have fine control over its tiling and offset, so that you could use those parameters to align the texture with the other rooms.
Correct.
And we're just keeping things simple and fast.
So we've got the first cube, drag it into the hallway. Now we need to create another cube. This cube is going to act as one of the hallway walls. So height is going to be 2. Z will actually be 2. We'll make it 10 units long. We'll make it 4 units high and 0.1 units thick. So that gives us our first wall. I'm going to apply the wall material to it because, once again, I'm going to be duplicating this, so it just saves me a step. So Control D to duplicate it, and I can bring it over. And this is going to be, looks like -4 here.
Yeah.
So that gives us, actually it's a little bit off.
That is a little bit off.
Yep. So our first one, let's bring this out. So it's 2. Bring this out. So that one is -2. Now this is one of the problems that happens if you create your hallway and you forget to zero out all your units. So what I'm going to do is I'm going to go ahead and zero out my transforms. Now, one of the things I do is I like doing simple hierarchies. It makes it simple. But if you forget to zero things out, once you start bringing in children, if you didn't zero out your parent object, you can get some really bizarre results with your numbers. So
yeah, just keeping in mind when creating a hierarchy, you know, it's all about being relative to the parent. So your children are being relative to the parent's transformation in 3D space. So where the parent is world, then everybody up underneath it, the center of their world is the parent, wherever he is at.
And because I didn't center it out, everything was shifted, and the numbers that I was getting were a bit awkward. That's where it makes it harder if you're a person that likes to type in your numbers. Not so hard if you get used to the snapping, because then you
maybe
just
we'll do another
everything.
video at some point, show them how to make a little panel that just has a create zeroed out, and then just kind of like in 3ds Max. So you have empty game object, cube, sphere, etc. Just an idea. Yeah, it'd be fun.
It'd make life a lot simpler. Alright, so I just made another cube, dialed in some numbers, positioned it so it sits right on top of the hallway walls. I'll apply a material to it, and I'll drag it into our hallway hierarchy. So that gives us all of the rooms that we need for our geometry, and we can actually move our camera inside, and we can see we've got one room that is connected to another room via a hallway.
Let's make some props.
Alright, let's make some props. So we'll create another game object. I'll rename it using F2. We'll call it props.
And the reason that we're adding some props into the rooms, again, is to help demonstrate what's taking place when we are taking advantage of occlusion culling.
So I've got my props game object, zero out all my transforms to make life easier a little bit. And we'll create another game object. This time I'm going to call on cylinder. Let's bring a cylinder in. So we'll bring it into the room. Let's size it up. So we'll make it 0.25, 0.6, 0.25, and we'll set its Y to 0.6 high. That'll get it to rest right on the floor. So we'll maneuver it into place. Want to line it kind of up against this wall, say about here. But it doesn't have a material, so I'll create another material to go with this one. This material I'll just call yellow, or yellow. I don't even know how to pronounce that. That was so good. Alright, so we'll call this one yellow. I'm going to make it a specular. I called it yellow, so I might as well make it yellow. So
That makes some sense.
So not orange, yellow. Lime green. Alright, I already got that for the walls. So set up its spec a little bit more. Drag this onto our little cylinder. Move our cylinder into the props window. So now I've got it selected. I'm going to duplicate it. I'm going to move it over a little bit. Duplicate it again. Move it over some more. Select all three of these. Duplicate them again. And then move all three of these to the other side of the door. So that'll take care of some props for this room.
Okay.
Now come over to the other room. Create another game object. This time we'll bring back our sphere. We'll bring them into the room. Say about here. We'll set his scale to 2. Set his Y to 1. That way he's resting right on the floor. And we'll kind of tuck him back into this corner. That way we've got something in this room that will be occluded by the walls when the camera's looking down the hallway.
Sounds good.
So he needs a material too. Let's create another material. This one we'll call red. Z. Alright, how about red instead? Again, we'll call on specular because it's always nice to have a shiny red ball in your scene. It's almost like a requirement. All test levels really need to have a shiny red ball. What do you think?
Okay.
Well, you're the one that wanted the last one.
I'll just go with it. It's good.
Alright, so we've got our sphere. We're going to put it in the props folder. So now let's go back and to each of our top levels and hit static to make sure that all of our objects are indeed static. So, and the only ones we should have to do is props and hallway because we didn't do those. Room 2 is going to be static because we had already flagged room 1 to be static and we just duplicated it.
Exactly.
So
Let's throw some lights in now.
alright, let's get some lights. So I'm going to back out a little bit and I'm going to start off with a point light. This first point light I'm going to position at 0. Let's go with 4.8 because our walls are 5 high. Set it Z at 0. That should put it at the top center of this room right here. Let's adjust its intensity to be 3. Those, if it is a hospital or so, it needs to have those really bright, static, or really white lights.
The very
Sterile.
bright,
the
fluorescent
sterile
lights.
Yeah. So let's go ahead and add some soft shadows. This isn't going to give us a problem because our lighting model is deferred. If we had forward lighting model set right now, we'd get a little error.
Yep, you wouldn't be able to do that. Little warning guy saying no.
Right, so we've got our first light. I'm going to go ahead and select it, duplicate it, and I'm going to move this one 20 in Y. That'll center them up in, 20 in X. That'll put them in the next room.
And again, just a quick reminder for anyone that may be watching this video where they skipped over the lighting section. The deferred lighting is only available in Unity Pro.
I'm going to take one of our point lights. I'm going to duplicate it. I'm going to position it at 10. It's actually outside of our level. So I'm going to bring it in to say about 3.1. Bring its intensity down to
0.7 or so.
Let's try
Okay,
0.6.
0.6.
I think 0.6 is a good one. And we're going to bump up its range to 15. 15, not 150. Wow, I really want 150, but
apparently
yeah,
so.
But I'm going to make sure that it's 15 instead.
So let's step inside real quick just to see what it looks like before we throw in our outside light.
All right. So
Hey, look at that.
So now we've got some light.
And some shadow. Very nice.
So
an outside light. Now we're adding in an outside light to aid in our visualization presentation of occlusion culling. It's just going to make it a lot easier to see what's happening with our geometry from the outside if it's lit.
Right, our character can never go outside. There's no windows in this level, so technically if that was all there was, you would never need a light on the outside. But because we want to demonstrate what is happening with our level and our geometry that's going to be disappearing and reappearing as we move the camera around, this just makes it a lot easier to visualize what's going on.
That's right.
And I'm going to set up some soft shadows so I can position the the direct light so it shows off everything to the best advantage. course, I'm getting nitpicky with the light. There we go. So if we spin around, we can actually make out the shape of the exterior of the level much easier than if we just left it flat lit.
Now, at this point, we could end everything and in the next video just begin showing what happens when we start utilizing occlusion culling, but we would have to manually drag our camera around to simulate what a player would be seeing. And to simplify this, we can just take advantage of the really cool character rig that we have, the whole setup that we'll begin teaching in the next video series, I do believe, or a couple video series down the road. Not sure which one, but
well, yeah, it begins in the next one. And
well, the next one we're gonna
give
them the videos on how to go about making their own little utility for light mapping.
Oh yeah, I forgot about that one.
So but coming up very soon. But let's go ahead and use it, so everybody again gets a quick preview of what we're going to be teaching them how to do soon enough.
Yeah.
And of course, when we're going to release these for free, but we'll also release the HD version, and with the HD version, the character and all the assets that were created in-house, along with the rig, etc., so that anyone that wants to use it, those people will have a full commercial license to use it in any game.
Right, and it's really simple to use. All you do is come down to your project, right-click, import package. We're going to go back to our source assets. Inside of here, I have put in a package called 3D Buzz Third Person Setup. We select it, hit open, give it a sec to decompress the package, and then it's going to show us a list of all the assets that are inside of that package. Just make sure everything's selected, hit import, and it's going to go through and import the FBX, the animations, the PSD files, and a couple other textures that we use for our character. And when everything's done, it's going to create a new folder, and it should be done here in a sec. And here's our new folder called 3D Buzz Third Person Setup. To use it, all you have to do is expand the folder, find the prefab called character, drag it into your scene, and hit play.
And we're done.
That's it.
That's it.
So now you have a third-person camera with a character that is fully animated that you can use to run around inside your scene.
Very simple scene. 2 rooms, a hall connecting them, and some props. And again, we'll be using this room over the next few videos for demonstrating the parameters available in occlusion culling. So with that, that is going to wrap up this video. We'll see you in the next one. Thanks a lot.